how are you? I hope you all are doing well, very safe at home. And yes, as we all know, I am dealing with the subject EST 130, that is Basics of Electrical and Electronics Engineering, in which we are dealing with the part A, that is Basics of Electrical Engineering. And the Basics of Electrical Engineering syllabus consists of two parts. That is, first one is a DC circuit and the second portion is the circuit analysis. So before starting the section, please put your attendance. For that, you have to click on mark your presence text in your Google slide, so it will redirect you to the normal Google form. Okay. So today's discussion will be mainly on Ohm's law and Kirchhoff's law, which we haven't studied in our last classes, and then we will rewind or refresh all those topics like series and parallel connections, current and voltage division rule in our first module, first part. Okay, so the only one remaining portion is left in our first module, part 1. That is first part, that is star and delta transformation, which we will discuss it on our next class. So today we are discussing one of the most important university portion, that is Ohm's law and Kirchhoff's law. So first one, what is a DC circuit? We know that a DC circuit is formed by a closed path which is followed by a direct current. Okay, so what is a DC circuit? DC circuit is a closed path in which a direct current flows through it. Is called a DC circuit. So what are the components of a DC circuit, or how can we form a DC circuit? Naturally, in a DC circuit, we need the current flow. Okay, so for the current to flow, we need a source. Then it should have a load to which the current is giving, and there should be a closed path between the source and the load. So naturally, we have already studied a DC circuit consists of a source, a load, and a closed path or a conductor to form a closed path. So today we are going to discuss first on our Ohm's law. You have already studied what is an Ohm's law or states Ohm's law. So first of all, we should say Ohm's law. Ohm's law is a basic law regarding or the fundamental law governing the electrical and electronic circuits. In an Ohm's law, we are relating current, voltage and resistance or impedance of a component. Okay, so first of all, we are determining whether our element, that is, we have studied three elements, that is resistor, inductor and capacitor. This Ohm's law determines whether these elements are linear elements or non-linear elements, that we will study in our further classes also. So first, if we are going to discuss on the Ohm's law, first question that is to be asked in the university examination is what state Ohm's law. So Ohm's law states that at a constant temperature, the ratio of potential difference between the ends of the conductor to the current flowing between them is a constant. That says that the ratio of potential difference, that is voltage to the current, that is voltage, ratio of voltage and current, that is V by I, is a constant. Ohm's law states that at a constant temperature, the ratio of voltage and current is a constant. Okay, so first you have to study the statement. Ohm's law states that at a constant temperature, the ratio of potential difference between the ends of the conductor to the current flowing between them is a constant. Topic we are going to, this slide shows topic we are. So from the previous slide we have stated what is an Ohm's law. So, going more into the details of the Ohm's law, from the name itself we know a man named George Ohm published this formula in 1827 based on his experiments with electricity. So, this law, actually, we know it is a fundamental law related to the electrical and electronic circuits, and it gives a relation between voltage and current. So we can, from this particular law, we can interpret voltage and current in three different ways. That is, in the first way, we can think that the current is directly proportional to the voltage and inversely proportional to the resistance, which means that an increase in voltage will increase in the current. If we are increasing the potential difference between the conductor, the current through the conductor will also increases if the resistance is a constant. Or I can interpret that as the current through the conductor is increased, the potential drop or the potential or the voltage across the conductor should also increase if the resistance remains unchanged. Or we can say, in a circuit, if we are taking the voltage and current, if the current is held constant, an increase in voltage results in increase in resistance. So, in short, we can say in an Ohm's law, or Ohm's law gives the relation between the voltage across a conductor or a component to the current flowing through the circuit. So, from this law, we can say that the ratio of this voltage between the conductor or the voltage between the terminals of a component to the current flowing through the component is always a constant. That is, V by I is a constant, and we can replace this particular constant with the resistance term R. So, we can say V is equal to IR. So, if in a circuit the voltage, the ratio of voltage and current are constant, then we can say our circuit follows Ohm's law and our circuit is a linear circuit. If a circuit element follows the Ohm's law, we can call that particular circuit as a linear circuit. So, what do you mean by a circuit is a linear circuit? It means that an increase in the voltage will result in an increase in current in the circuit if the resistance of the components are kept constant. Not only the resistance, the same will follow with the inductor and the capacitor. In the last class, we have discussed on the inductors and capacitors, isn't it? We have derived the formulas for voltage and current. So from those derivations, we know in resistor as well as the inductor and capacitor, the ratio between the voltage and current is always a constant. So we can say the resistance, inductance and capacitance follows Ohm's law if they are linear circuits. If they are following Ohm's law, then that particular element is a linear element. Okay. And in university, in some public service questions or PSC questions, objective type questions, they will ask if the inductor is iron core inductor, then we can't say it is a linear element, because when the core is iron, we will discuss in our second module, there will be magnetism, saturation will be there. At that time, our inductor will not be a linear element. If the inductor is an air core inductor, then our circuit will be a linear element. If our circuit is a transformer, if our inductor works as a transformer or an iron core inductor, then it will not follow Ohm's law, and that particular inductor will not be a linear circuit element. So in public service questions, or that is PSC questions, or in junior engineering examination questions, they will say identify the linear element. They will give air core inductor, iron core inductor, resistor, like that. They will give, or identify the non-linear element. They will give air core inductor, iron core inductor, transformer, like that. In that, only air core inductor capacitor, and the resistor are linear elements, whereas transformer or iron cord inductor all are non-linear elements. So I hope you understood what is an Ohm's law. An Ohm's law states that, can you tell me what an Ohm's law states? An Ohm's law states that at a constant temperature, the ratio of the potential difference between the ends of the conductor to the current flowing between them is a constant. So if you are increasing the current, the voltage will also be increasing in that particular component. Or in other words, if I am increasing the voltage applied across the component, then naturally the current will also increase. That is shown in our graph. You can see this graph. That is, when current increases, voltage increases. When current is zero, voltage is zero. So this particular Ohm's law, this particular VI characteristics, voltage current graph, is a graph for resistance. Okay, so you can understand that if the circuit element passes through, sometimes in PSC questions or multiple choice questions, they will give different graphs and they will ask us to find out the linear element. There also we should understand the graph should pass through the origin line with a constant slope. Then only we can say our circuit is a linear circuit element. This graph can flow like this, or it can move on the left side, right side, but still it should be, the slope should be a constant and then should pass through the origin. Then we can say our element is a linear element. An element is called a linear element when it follows the Ohm's law. I hope you understood it. Topic we are going to discuss is Kirchhoff's law. Kirchhoff's law is also one of the most important university question. From the name itself, we know Kirchhoff's law is named after, or it is first, or the Kirchhoff's law is a result of the research conducted by a German physicist, Gustav Robert Kirchhoff. From the name itself, the law got Kirchhoff's law. Actually, there are two laws. These laws are formed as a result of his research on the conduction of electricity in a closed electric circuit. So we know Kirchhoff's law is one of the fundamental laws other than Ohm's law in an electric circuit, and actually this Kirchhoff's law deals with the conservation of current and energy. First one is conservation of current, that is, what is conservation of energy? Energy can neither be created nor be destroyed. The same thing the Khrushchev is also trying to say in his first law. That is Khrushchev's law. We will discuss in our next slides. This slide shows the previous year university questions. From this we can say this is a repeatedly asked question for our university exam, that is state and explain Kirchhoff's law with examples. It is asked in 17, 18, 19, that too in regular exams as well as in supplementary exams. Okay, so this is a very important question and you have to study Kirchhoff's law, that is Kirchhoff's current law as well as Kirchhoff's voltage law with example. So Kirchhoff to summarize, the Kirchhoff's current law states that at any junction in an electric circuit, the total current flowing towards the junction is equal to the total current flowing away from the junction. Okay, so Kirchhoff's first law states that the total current entering at a junction, or we can say a node, that is a junction or a node is a place or a point where two or more elements connect together in an electric circuit. So the total current entering the junction or a node is equal to the charge leaving the node as no charge is lost. That is also Kirchhoff's first law. Okay, so easily we can say, according to the Kirchhoff's current law in a circuit, the total of the currents entering in the junction is equal to the total of the current leaving the junction. Okay, and this law can be called as Kirchhoff's first law or Kirchhoff's current law, or we can say Kirchhoff's laws on conservation of charge. Okay. To summarize, the Kirchhoff's current law states that the total current entering at a junction or a node is equal to zero. Okay, that is the current entering the circuit or flowing towards the junction is equal to the total current flowing away or leaving the junction. So in mathematical terms, we can say sigma I, the total current is equal to zero. So usually we are assuming that the incoming currents we are taking it as positive and the outgoing currents we are taking it as negative. So the total current should be equal to zero in a Kirchhoff's current law. So while you are asked to state the Kirchhoff's current law, you have to state it. You have to provide the mathematical equation, and next what you have to do is you have to write an example. Okay. So this is the example for a Kirchhoff. So this is the example. So why? So this is the example. So this is the example for a Kirchhoff's current law. In the diagram, you can see we have different currents. That is I1, I2, I3, I4, and I5. So the junction consists of 5 elements which are connected together, and we have 5 currents starting from I1, I2, I3, I4, and I5. Now we have to apply Kirchhoff's current law in this particular equation. So in the last slide, I have told you that if the current is coming towards the junction, then we are taking it as positive, and if we are if the current is leaving the junction, then we will take it as negative. So what we will do, I1 is entering the junction, so I1 will be positive. I2 is entering the junction, so plus I2, and I3 is leaving, so we have to give minus, so minus I3, and I4 current is also leaving, so minus I4. I5 current is also leaving, so minus I5 is equal to 0. Okay, so while solving for such a question, what you have to do is we have to assume the direction. If the directions are not given, we have to assume the direction, or if the direction is given, then we have to take the incoming currents as positive and outgoing currents as negative in a Kirchhoff's current law. Let's check the answer now. So this is the example for a Kirchhoff's current law. In the diagram, you can see we have different currents. That is I1, I2, I3, I4, and I5. So the junction consists of 5 elements which are connected together, and we have 5 currents starting from I1, I2, I3, I4, and I5. Now we have to apply Kirchhoff's current law in this particular equation. So in the last slide, I have told you that if the current is coming towards the junction, then we are taking it as positive, and if we are if the current is leaving the junction, then we will take it as negative. So what we will do, I1 is entering the junction, so I1 will be positive. I2 is entering the junction, so plus I2, and I3 is leaving, so we have to give minus, so minus I3, and I4 current is also leaving, so minus I4. I5 current is also leaving, so minus I5 is equal to 0. Okay, so while Kirchhoff's voltage law, also known as the conservation of energy, law related to the conservation of energy. Kirchhoff's voltage law states that in any closed loop of a network, the algebraic sum of the voltage drops taken around the loop is equal to the resultant EMF acting in that loop. I repeat, Kirchhoff's voltage law states that if we, in a circuit, if we are taking in a closed path or a closed loop, if we are taking the algebraic sum of the voltages across a closed loop, then it will be equal to 0, or in other words, the algebraic sum of the voltage drops taken around the loop is equal to the EMF acting in that loop. Okay, so in short, how can we say the voltage around the loop equals to the sum of the every voltage drop in the same loop for any closed network and is also equal to 0. The voltage around a loop equals to the sum of every voltage drop in the same loop for any closed network and is always equal to 0. So in the exam, if you are asked to state the Kirchhoff's voltage law, you have to state that in any closed loop in a network, the algebraic sum of the voltage drops, that is the products of current and resistance taken around the loop, is equal to the resultant EMF acting in the same loop. Okay. So let us So, while solving for Kirchhoff's second law or Kirchhoff's voltage law or Kirchhoff's conservation of energy, first what we will do is we will assume a direction. Okay, we will assume the direction of the loop and we will find out the sum of all the voltage drops across the loop, sum of all the voltages across the loop. Okay, so the voltages we have already studied in our previous classes that voltage can be either the potential or a voltage, that is a drop that is occurring across the resistance or the elements, and as well as it can be the EMF, electromotive force generated. Okay, so the voltage can be a source voltage or an EMF as well as a consumed voltage or a load or a potential. Okay, or the work done by the voltage, that is potential. So while solving this Kirchhoff's voltage law, what we will do is we will take the sources EMFs as positive and the drops, voltage drops or the potential drops as negative. In current law, what we have taken is we have assumed the direction for the currents and we are taking the incoming currents as positive and the outgoing currents as negative. In Kirchhoff's voltage law, first what we will do is we will give the source voltages, EMFs, electromotive forces or voltage sources as positive and the voltage drops or voltage consumption, potential drop, we will take it as a negative. And we will assume the direction for a loop which will be same as the current direction. So we will assume a direction, either the direction will be clockwise or anti-clockwise. And while solving this, we will check for the direction or the sign at the leaving terminal. We will check for the sign at the leaving terminal and we will form the equation. I will tell you with the help of the example so that you will better understand easier. Okay. Let us consider the example given in the circuit. Okay. So how will we solve for the Kirchhoff's voltage law? In the present circuit, there is only one loop. Loop is a closed path. What is a loop? Loop is a closed path. So what we will do is we are going to employ Kirchhoff's voltage law in the single loop. For that, first we have to assume the direction. Here, the current direction is assumed as I is flowing anti-clockwise direction. You can see the arrow at the positive terminal of our battery or source E1. So at the positive terminal of E1, we have the voltage, we have the currents. Okay, so the current leaves from the positive terminal of E1 and it enters to the positive terminal of E2. It leaves through the negative terminal of E2 through the resistance R2. Then it flows to the resistance R3 and finally to R1 and it returns to E1 through the negative terminal. So what we will do is we will take this single loop and the current direction is anti-clockwise. And I have already already told you we have to take the voltage sources as positive and resistances as negative. So how will we form it? That is, here the current from the source E1, the current is leaving through the positive terminal. So E1 is plus. And then in E2 we have the current leaving at minus terminal. So what is it? So in the voltage sources, we have two voltage sources, E1 and E2. The current leaves E1 through positive terminal, so E1 is plus, and current leaves E2 through negative terminal, so the sign is minus. So E1 minus E2. Then voltage drop across R1, R2, R3. So that should be minus voltage across R1 minus voltage across R2 minus voltage across R3 will be equal to 0. Okay, so let's check. Okay, so you can see the answer. The answer is E1 minus E2 minus potential drop across R1, that is I into R1 minus I into R2 minus I into R3 is equal to 0. That we can also see the sum of the potential drop is equal to the, what is it? The sum of the potential drops is equal to the resultant EMF acting on the loop. So what is the resultant EMF for the voltage source acting in the loop? That is E1 and E2. So current leaves E1 through positive terminal, so plus E1, and current leaves E2 through negative terminal, so minus E2. And the sum of the EMFs acting is equal to the sum of the potential drop. So what is the potential drop? Voltage across R1, that is I into R1, voltage across R2, that is I into R2, and voltage across R3, that is I into R3. So we can write E1 minus E2 is equal to I R1 plus I into R2 plus I into R3. Or we can modify it as I into R1 plus R2 plus R3. Okay, so anyway you can write like this. So I hope you all understood it. Okay, do I have to repeat it again? ഒരു പ്രാവശ്യം കൂടെ പറഞ്ഞു തരണോ? പറഞ്ഞു തന്നേക്കാം, ഒരു പ്രാവശ്യം കൂടെ പറഞ്ഞു തന്നേക്കാം. എങ്ങനെയാ ചെയ്യേണ്ടത്? കിർച്ചോഫ് വോൾട്ടേജ് ലോ വരുമ്പോഴത്തേക്കും നമ്മൾ ഏത് ഡയറക്ഷൻ, ഒരു ലൂപ്പ് എടുക്കും, ആ ലൂപ്പിന്റെ ഡയറക്ഷൻ നോക്കണം, കറണ്ട് ഡയറക്ഷൻ. ഒന്നില്ലേ അത് ആന്റി ക്ലോക്ക് വൈസ് ആയിരിക്കും, ആ ലൂപ്പിലല്ലേ ക്ലോക്ക് വൈസ് ആയിരിക്കും. നമ്മൾ എന്നിട്ട് വോൾട്ടേജ് രണ്ട് ടൈപ്പ് ഉണ്ട്. സോഴ്സ്, വോൾട്ടേജ് സോഴ്സ് ബാറ്ററി ആണെങ്കിൽ അല്ല EMF ആയിട്ടുള്ളതിനെ കാണിക്കുകയാണെങ്കിൽ അത് പോസിറ്റീവായിട്ടും മറ്റേ കമ്പോണൻസിലെ റെസിസ്റ്റർ, ഇൻഡക്ടർ, കപ്പാസിറ്റർ അതൊക്കെ നെഗറ്റീവായിട്ടും എടുക്കണം. ഇനി അത് മാത്രമല്ല, പിന്നെ എന്ത് ചെയ്യണം, ഈ വോൾട്ടേജിന്റെ ലീവിങ് എൻഡാ നോക്കണ്ട, നമ്മുടെ കറണ്ട് പോകുന്ന എൻഡ്, കറണ്ട് ആ എലമെന്റിൽ കൂടെ ഇറങ്ങി പോകുന്ന എൻഡ്, ലീവിങ് എൻഡ്. എൻറ്ററിങ് എൻഡ് അല്ല, സ്റ്റാർട്ടിങ് എൻഡ് അല്ല, ഫിനിഷിങ് എൻഡ് ആണ് നോക്കേണ്ടത്. അപ്പൊ കറണ്ട് E1ന്റെ പോസിറ്റീവ് ടെർമിനലിൽ കൂടെ അല്ലേ ഇറങ്ങി പോകുന്നത്, അപ്പൊ അത് പ്ലസ് E1. കറണ്ട് E2ന്റെ നെഗറ്റീവ് ടെർമിനലിൽ കൂടെ ആണ് ഇറങ്ങുന്നത്, അപ്പൊ മൈനസ് E2. അത് രണ്ടും അപ്പൊ വോൾട്ടേജ് സോഴ്സ് ആണ്, ഈസ് ഈക്വൽ ടു അല്ലെങ്കിൽ മൈനസ്, ഇനി എല്ലാ ഡ്രോപ്പും കൂടെ ആഡ് ചെയ്യണം, മൈനസ് I into R1, അതായത് വോൾട്ടേജ് ഡ്രോപ്പ് അക്രോസ് R1 മൈനസ് I into R2 വോൾട്ടേജ് ഡ്രോപ്പ് അക്രോസ് R2 മൈനസ് I into R3 ഈസ് ഈക്വൽ ടു 0. അതാണ് കിർച്ചോഫ് വോൾട്ടേജ് ലോ. പിന്നെ അതിനെ ഒന്ന് റീഅറേഞ്ച് ചെയ്ത് എഴുതുന്നതേ ഉള്ളൂ. E1 മൈനസ് E2 ഈസ് ഈക്വൽ ടു IR1 പ്ലസ് IR2 പ്ലസ് IR3. ഇത് നമ്മൾ പ്രോബ്ലം ചെയ്യാൻ ഇത് ഇക്വേഷൻസ് use it. I hope you all understood it. So while solving for Kirchhoff's voltage law, we have to assign positive sign for the voltage sources and negative sign for the potential drops, and we have to assume a current direction, and we are giving the sign of the leaving end. Leaving end in the sign ആണ് കൊടുക്കുന്നത്. ഓക്കെ, അപ്പം E1 കൂടെ ലീവ് ചെയ്യുവാണെങ്കിൽ പ്ലസ് E1, മൈനസ് ടെർമിനലിൽ കൂടെ ലീവ് ചെയ്യുകയാണെങ്കിൽ മൈനസ് E2. ഓക്കെ, ഇത്രയേ ഉള്ളൂ കാര്യം. So today we have finished learning our Ohm's law and Kirchhoff's law. Those the first So today we have finished learning our Ohm's law and Kirchhoff's law. Those especially Kirchhoff's law is very important for our university examination. Next we are just refreshing the important topics which we have studied in our first week. That is, what are the different types of series circuit? The circuits, DC circuit is a circuit which is having a direct current flow, and it should consist of a source and a load, and the source and load are forming a closed path through the conductors. So what are the different types of DC circuits? That is, we are having series circuit, parallel circuit, and series parallel circuits or hybrid circuits. The first type of the circuit we are going to discuss is a DC series circuit. We know that in a DC series circuit, which is shown in the figure, we know that in a DC series circuit, the components are connected end to end so that the same current flows through the circuit. That is, in a DC series circuit, what we will do is we are connecting the sources end to end, which means that the finishing end of the voltage source is connected to the starting end of the resistor R1. The other end of the resistor R1 is connected to the one end of the resistor R2. That is, there the starting end is connecting to the finishing end of the other component, or the components are connected end to end so that there is only the same current flows through the circuit. There is only one current flow through a series circuit. So in a series circuit, the current flow is same because all the components are connected end to end. But the voltage from the circuit, we know in the circuit we have a voltage source Vs and resistors up to Rn. So we know that the voltage drops across resistor R1, VR1, VR2, VR3. All those are different, but the same current flows through the resistance R1, R2, R3, etc. Rn. So what is the voltage drop across R1? VR1, that is equal to I into R1. What is voltage drop across R2? That is VR2 is equal to I into R2. What is the voltage drop across Rn? That is, we notate it as V suffix Rn, and Vrn is equal to I into Rn. Okay, so since the resistance values are different, even though the current is same, the voltage drop appearing across different elements in a series circuit will be different. So how? Now we So how can we find out the current through a series circuit? In current through a series circuit will be always same. For a current through a series circuit will be always same, that we know. But how will we find out the current through a series circuit? So we have the voltage source Vs and different resistances R1, R2, R3, etc. Rn. Okay. So according to the this Ohm's law, we can see that V is equal to I into R. Here, if we are applying the same in the circuit, V is the total voltage. So that is Vs is equal to I into R total. So how can we find out the current I? I is equal to Vs divided by R total. That is, current I is equal to, we can solve it by finding out current I is equal to Vs divided by R total. Okay. Now we have to find out what is this R total. In order to find out this R total, what I will do is I will apply Kirchhoff's voltage law in this particular series circuit. If I am applying Kirchhoff's voltage law in this particular series circuit, we know that the voltages in a voltage law, we will take the source or EMFs as positive and drops as negative. So what I will do is I will take this voltage source. What is this voltage source? Vs, and the current is in the clockwise direction. So if I am applying this, the current is leaving through the positive terminal. So plus Vs and voltage drop minus VR1 minus VR2 minus VR3 minus Vrn is equal to 0. Or I can say Vs minus what is VR1? VR1 is I into R1. So Vs minus I into R1 minus I into R2 minus I into R3 etc. minus I into Rn is equal to 0. If I am rearranging my equation, we can say Vs is equal to I into R1 plus I into R2 plus I into R3 plus etc. I into Rn. So here the current I is same throughout the equation. So I am taking I as a common. So we will get Vs is equal to I into R1 plus R2 plus R3 plus etc. Rn. So this is of the same form that Vs is equal to I into R total. From that we can understood that R total is equal to R1 plus R2 plus R3 plus etc. Rn. So in a series circuit we understood that the total resistance R total is equal to the sum of all the resistance, that is R1 plus R2 plus R3 plus etc. Rn in a series circuit. So next what we will we have to find out, or we have studied our voltage division rule. So in the last slide we told that even though the current is same in a series circuit, the voltages are different for different components. So how can we find out the voltage division rule in a circuit? That is, my aim is to find out the voltage across a particular element if we are given the source voltage to this series circuit. So in order to find out this, first I am applying Kirchhoff's voltage law. So here it is only one voltage source Vs and the current is leaving through the positive terminal. So plus Vs minus I into R1 or minus VR1 minus VR2 minus VR3 minus Vrn is equal to 0. And if I am substituting this VR1 is the voltage drop across the resistance R1, that is V is equal to I into R. So VR1 is equal to I into R1, VR2 is equal to I into R2, VR3 is equal to I into R3, Vrn is equal to I into Rn. So I am substituting this in our Kirchhoff's voltage law. Then we can write my equation as Vs minus I into R1 minus I into R2 minus I into R3 minus I into Rn is equal to 0. From this we are going to find out our voltage rule. So my aim is to find out the voltage across the resistance R1. So next what we will do is we have to find out the voltage drop across the resistance R1. So voltage drop across the resistance R1 is I into R1. So we don't know the value of current I. But from the previous slide we know that Vs is equal to I into R1 plus R2 plus R3 etc. up to Rn. So if we have to find out the current, then current I is equal to Vs divided by R1 plus R2 plus R3 plus Rn, that we have derived from our previous slide. So what is our aim? My aim is to find out voltage across the resistance R1, that is equal to I into R1. In place of I am substituting the equation, that is Vs divided by R1 plus R2 plus R3 plus etc. Rn. So if I am substituting it, then I can say Vs into R1 divided by R1 plus R2 plus R3 plus etc. Rn. So how can we say what is a voltage division rule? Voltage division rule states that the voltage across the resistor in a series circuit R is equal to the source voltage times the ratio of that particular resistor R divided by the total resistance in our circuit. That is, if we have to find out the voltage across the resistor R1, then we have to multiply the source voltage Vs into R1 divided by sum of the resistances in that loop, that is R1 plus R2 plus R3 plus etc. Rn. Okay. Or if we have to find out the voltage drop across resistor Rn, then Vrn is equal to source voltage Vs into Rn. Rn divided by R1 plus R2 plus R3 plus etc. Rn. So can you say what is the voltage drop across the resistor R3? VR3, that will be equal to voltage source Vs into R3 divided by R1 plus R2 plus R3 plus etc. Rn. In short, if I am summarizing the main points from our DC series circuit, then we can say in a DC series circuit, the components are added or connected end to end so that there is only the same current flows through the circuit. So there is only one value of the current for a series circuit. And we know that the sum of the resistances in a series circuit is equal to the total resistance. The total resistance is equal to the sum of the individual resistance in a circuit. That is, R total is equal to R1 plus R2 plus R3 plus etc. Rn in a series circuit. Next, we have studied the voltage division rule. That is, the voltage across the resistor R1. VR1 is equal to VR1 is equal to I into R1, or we can write it by using the potential divider rule or voltage division rule as Vs into R1 divided by R1 plus R2 plus R3 plus etc. Rn. Or according to the voltage division rule, the voltage across the resistor R in a series circuit is equal to the source voltage times the ratio of the resistor R divided by the sum of the total resistances in that series circuit or a series path. Okay, now we will see what is a parallel circuit. Next is a DC parallel circuit. In a DC parallel circuit, as shown in the diagram, a DC parallel circuit has each end connected to a common point. That is, in a parallel circuit, the starting ends will be connected to a common point, while the leaving ends or the finishing ends are connected to some other common point. Then we can say that particular circuit as a parallel circuit. Okay, so in a parallel circuit, what is the advantage of connecting the things in parallel? That is, from here in the circuit we are having two resistors R1 and R2, and we are also having a voltage source Vs. So we know that the starting and plus terminals are connected together in the together, and the leaving ends, that is minus terminals, are all connected in the together to form a parallel circuit. So here from the Vs, a total current I total will leave the source voltage Vs, and it splits and enters the current I1 through the resistor R1 and current I2 through the resistor R2. Okay, so even here, unlike in the series circuit, the current flowing through the components are different in a parallel circuit. While we were discussing the series circuit, we know the same current flows through all the components in a series circuit, whereas in a parallel circuit, different current flows through the different components. But here the potential, even though different current flows through the different components, but when they are connected in parallel, the voltage across all the components will be same. That is a peculiarity of a parallel circuit. So in a DC series circuit, current is always same in all the components of a DC series circuit, whereas in a DC parallel circuit, the voltage will be same across all the components. Okay. So in this parallel circuit, next what we have. So in this parallel circuit, if you are going to find out the total current IT, then IT is equal to Vs divided by the R total, that is the total resistance in the circuit. So the total current will be equal to the source voltage Vs divided by total resistance. If it is so, then can we write out our voltage Vs? That is, Vs is equal to IT, I total into our resistance R total. Okay. So we know our source voltage Vs will be equal to the total current into total resistance. So what I'm going to do is, as if we have applied Kirchhoff's voltage law in our first series circuit, I am going to apply here Kirchhoff's current law. So according to Kirchhoff's current law, we know that the sum of currents entering the circuit will be equal to the sum of the current leaving the circuit. So the total current IT will be here. IT splits into I1 plus I2, or if I am applying it, the entering current at junction is IT and leaving is I1 and I2. So I can write it as IT is equal to I1 plus I2, or I can write it as IT minus I1 minus I2 is equal to 0, or IT is equal to I1 plus I2. So now what I am going to find out is, what is IT? IT is the total current that we have already studied. IT is equal to Vs divided by R total. So IT is Vs divided by R total. What is I1? I1 is the current through the resistor R1. So that is V by R. That is V by R1. And what is current? I2? I2 is the current through R2. That is V divided by R2. So if I am rewriting the equation in elaborated form, IT is equal to I1 plus I2, I can write it as Vs divided by R total is equal to Vs divided by R1 plus Vs divided by R2. So we know that for the equation, the term Vs is present in the left hand side and the right hand side of the equation, so we can cancel it. So finally we will get 1 by R total is equal to 1 by R1 plus 1 by R2. And if we are having 4 resistances, then 1 by R total is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. So we can say the total resistance in a parallel circuit is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Okay, or if we are having only 2 resistance R1 and R2, then we can write R total is equal to 1 by R total is equal to 1 by R1 plus 1 by R2. If I am solving this, then I will get 1 by R total is equal to R1 plus R2 divided by R1 R2, and that is R total is equal to R1 R2 divided by R1 plus R2. So that is, in a parallel circuit, the total resistance is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus etc. Okay. Next, what we have to study is a current division rule. So we know that in a parallel circuit, the potential across the parallel paths are equal. But we know that the current in the different paths are different. Okay, because the current is different. So what we have to do is, why it happens? Because the voltage across each of the parallel path is same, but the value of the resistances at each parallel path is different, so that the current value I is equal to V by R. V is same, but R1, R2, R3 etc. are different, so we are having different currents. So first we have to find out what is the current through the resistor R1. So we have to find out the current through resistor R1. So total current will be, the total current will be, we know, V divided by R total. I is equal to V divided by R total. Similarly, if the voltage across the resistor R1 is VR1, then what is the current through resistor R1? That is VR1 divided by R1. Or what is VR1? VR1 is same as the source voltage, because parallel circuit. In a parallel circuit, Vs is equal to VR1 is equal to VR2, or we can say Vs is equal to V1 is equal to V2. So current I1 will be equal to V divided by R1, that is V is Vs, Vs divided by R1. So current I1 is equal to Vs divided by R1. Then what I am going to do is, I am substituting for Vs. What is Vs? Vs is equal to I total into R total. So I can write out I total into R total divided by R1 is equal to, what is equal to our current I1, and we have to find out R total. What is R total? R total is equal to, if there are having two resistances, then R total is equal to R1 R2 divided by R1 plus R2. The same equation we have substituted in the in place of R total. Okay, so I can rewrite my equation as IT into R1 R2 divided by R1 plus R2 divided by R1. So the denominator, there is an R1, as well as the numerator is also, we are having an R1. Both will cancel out, and finally I will get the current through the resistor current through the resistor R1 is I1. That I1 is equal to IT, total current, into R2 divided by R1 plus R2. I repeat, here in a current division rule, we have to multiply the source current with the opposite resistance divided by sum of the resistance in the parallel path. I hope you understood. While applying current division rule, what we have to do is, if we have to find out the current through the resistance R1, then we have to multiply the source current, or IS or IT, into R2 divided by R1 plus R2, if we have to find out voltage across R1. Sorry, current through R1, that is current through R1 is equal to IT into R2 divided by R1 plus R2. In short, slide shows. In short, if I have to summarize this parallel circuit, what is a parallel circuit? In a circuit where the similar ends are connected to a common point. That is, in a parallel circuit, the starting ends are connected to a common point, while the finishing ends are connected to some other common point. So, in a parallel circuit, the potential across all the parallel paths will be equal. And after that, we have found out the total resistance. The total resistance equation is 1 by R total is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Here I forgot to tell you what is 1 by R total. 1 by R total is the inverse of resistance, that is conductance. So 1 by R total is capital G total. G total is equal to 1 by R total. So from the equation, 1 by R total is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus etc. 1 by Rn. We can simply find out as G total is equal to G1 plus G2 plus G3 plus G4. So in a series circuit, the total resistance is the sum of the individual resistances, whereas in a parallel circuit, the conductance, total conductance is equal to sum of the conductance of the individual elements. Okay, now what we have to find out is, we have to find out the current division rule. So if we are, suppose we are having two resistors R1 and R2, and we have to find out the current I1 through the resistor R1, then we have to multiply the source current IT into the opposite resistance, that is R2 divided by sum of the resistances R1 and R2. Okay, so what is that? According to the current division rule, the current through a resistor, in this case R1, if the current through the resistor R1 we have to find out, then we have to multiply the source current, that is I total, into R2 divided by R1 plus R2. Okay. Similarly, if we have to find out the current I2 through the resistor R2, then we have to multiply the source voltage into R1 divided by R1 plus R2 in order to find out I2. Okay. So these are the main points of a parallel circuits. Okay. So now we are summarizing the current division rule and voltage division rule. So in the university examination, nobody will ask you what is a series circuit or a parallel circuit, but they will ask you what is a voltage division rule or state current division rule with the help of an example. Then you have to write the C. Okay, so what is a voltage division rule? Voltage divider rule we have studied with the series circuit. In a series circuit, the elements are connected end to end so that the same current flows through the circuit. But in a series circuit, the voltage across a resistor R will be equal to the source voltage into that particular resistance R divided by sum of the resistance in that loop. Okay, so that or in that series path, that is voltage division rule. Whereas current division rule, we are explaining it in the parallel circuit. In a parallel circuit, similar ends are connected to a common point. That is, starting ends are connected to a common point, while finishing ends are connected to some other common point. That is a parallel circuit. And in a parallel circuit, we know that the voltage across the parallel paths is same, but the current is different. So how can we find out the current through a resistor R1 in the circuit given below? The current through resistor R1, that is I1, will be equal to the source current IT into opposite resistance R2 divided by R1 plus R2. I repeat, for a current division rule, we have to multiply the source current in with the opposite resistance to the sum of the total resistances in a parallel path. I hope you understood it. It is very important. Okay, slide shows the resistances in series and parallel. I am repeating this because it is also given in your university syllabus. So what will happen when the resistances are connected in series? Then the total resistance will be equal to the sum of the resistance. That is, R total is equal to here R1 plus R2 plus R3. And what happens when the three resistances are connected in parallel? Then 1 by R total is equal to 1 by R1 plus 1 by R2 plus 1 by R3. While solving this parallel circuits, if we find it out very difficult to find out 1 by R1, then what we can do it is, instead of summing 1 by R1 plus 1 by R2 plus 1 by R3, we will just find out 1 by R1, 1 by R2, 1 by R3, etc. and we will take the sum. So G total is equal to G1 plus G2 plus G3 for a parallel circuit. Okay, the same goes with the case of an inductor also. For an inductor, let me finish. For an inductor also, though it is not specified in our syllabus, but you have to just think that the inductor, the case of the inductor is very similar to that of a resistor. So if 2 or 3 inductors are connected in series, then the total inductance L total is equal to the sum of the individual inductance. That is, L total is equal to L1 plus L2 plus L3 plus etc. Ln. And if they are connected in parallel, then similar to the resistance, that is 1 by L total is equal to 1 by L1 plus 1 by L2 plus 1 by L3 plus etc. 1 by Ln. Okay, so the inductors follow the same pattern as that of the resistances in series parallel combination. While we are solving for the series and parallel combination of a capacitor, there is a difference. Okay, so what is the difference is, if the capacitors are connected in parallel, then we can take the sum of the individual capacitance. Okay, that is, if 2 or more capacitance are connected in parallel, then the total capacitance in parallel connection will be equal to the sum of the each capacitance. That is, C total is equal to C1 plus C2 plus C3 plus C4 plus etc. Cn if they are connected in parallel. But if they are connected in series, then what will happen? Then 1 by C total is equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus etc. 1 by Cn. Okay, so the resistance and inductors form the same pattern, whereas for capacitance it reverses. That is, in order to find out the parallel combination of the total resistance, we will sum out the individual resistances in parallel combination, whereas in order to find out the total total capacitance, then what we will find out, 1 by C total is equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus etc. for a series connection of capacitors. So though this is not specified in our university syllabus, but just sometimes it may help you to solve some problems in third module, and so I am just saying it for your knowledge. Series parallel combination of capacitance is just the reverse. When we are taking resistors and inductors, if they are connected in series, then total resistance will be R1 plus R2 plus R3, or total inductance will be the sum of the individual inductance. But it is opposite in terms of capacitance. For a capacitance, the total capacitance is equal to the sum of the capacitance only when they are connected in parallel. Okay, that is the difference. So let me finish with our today's lesson. I know today's lesson was a little lengthy, but we were just refreshing what we have studied in our last week. Okay, the first three classes. So I know my conversation was a little bit faster. So what you can do is you can just um, rehear it. Okay, you can again hear it by selecting the slide. So what you have to do is you have to play this presentation manually. Okay, you have to click on present and you have to move to each slide. So the voice recordings will not be loading if your net connection is slow. So what we have to do is we have to wait for a little time and you have to finish all your notes, and I'm uploading some questions, so you have to do the problems and submit in your Google Classroom. If you have these are before these are if you have any doubt or any questions, please feel free to ask me. You can ask through the comment sessions or you can ask through my WhatsApp. These are your homework questions. That is, first you have to state and explain the Kirchhoff's laws with example. So first you have to state Kirchhoff's current law. Then you have to write the mathematical equation sigma is equal to 0. Then you have to draw a diagram and you have to answer Kirchhoff's current law. Same you have to do for the Kirchhoff's voltage law also. You have to first state the Kirchhoff's voltage law. Then you have to write the mathematical expression after drawing the diagram. Okay, so this all expected from the first question. And the second question, that was a previous year university question, last year university question, asked for 10 marks. So they are simple problems. What you have to do is you have to just write the question and you have to write the given data and find out the equations and you have to find out the answers. Okay, don't worry, I'll discuss the answers so you don't have to worry, but you have to try to do some problems. So this is very important. You people take time and work out your assignment or a homework. Okay, so this is a homework for today's lesson. So after seeing this, watching this video, just try to do it and upload it in your Google Classroom. I will post the link for Google Classroom. Don't worry. Before leaving your presentation, please try to fill out this exit ticket. So after going through this exit ticket, then I'll understand how much you have enjoyed my class and what all things I have to do for you again. And so what you have to do is please fill the exit ticket before you leave the class. That's all for today. So have a nice day and happy learning. Okay, bye bye, take care.